Okay, so this is the first video in a series about graphing motion. Alright, so we're going to talk in this video about a certain kind of motion graph. It's called a distance-time graph. So this is going to tell us something about the motion of an object. Alright, so what we have on this graph is we're plotting the position of the object over time. So we've got time here on the x-axis. We've got the distance traveled on the y-axis, and we're plotting the distance from the starting point. So the starting point, the point where we started observing this object, is here at the origin, 0, 0. Okay, so as we're looking at the motion of whatever this object is, we can see that it starts out here with a constant slope of this distance-time line here. That means, we'll get into this in more detail in a minute, but that means that this is traveling at a constant speed through this section. And then you can tell how far has it gone in a certain amount of time. And right here you can see 3 seconds. Follow that over, it's gone 5 meters. And then after 6 seconds, it's gone 10 meters. Okay, so at 10 meters, at that distance, you see that's a flat line. On a distance time graph, when the line is flat, that means the object, for some period of time, has stopped moving. It's at 10 meters, and that distance is not changing. So it's 10 meters from the starting position. They stay there until 11 seconds, and so it's a 5-second break there that they just stop, whatever it is, the thing. And then it starts going back where it came from, but not at a constant speed. This is now at a changing speed because the slope is not constant. Right? And if we want, we can look at, say, 15 seconds time. They are now back at 5 meters again. So just as an example. Okay, so that's a distance time graph. We could even use this to calculate how fast what their average speed was. Say for the first 3 seconds we could do that. And we'd go basically 3 seconds, 5 meters. How would we calculate that? Well, distance over time gives you speed. So 5 meters over 3 seconds. And that doesn't work out very evenly, but we're looking at basically 1 2/3 meters per second, or 1.7. All right, I'll just write that down really quick. 1.7 meters per second. All right. So now here we are looking at a very basic graph to show you a very particular kind of motion that you can show on a distance time graph. All right, you can see this is really basic. There's not even any labels of numbers or anything. So what does this graph show right here? It's a flat line. Since this is a distance time graph, the flat line essentially means that the object is stationary. It's not moving. All right, it's at some distance. It's not at the starting point, right? Because the starting point is at the origin. So whatever this thing is, it's moved some distance and now we're watching it, but it's not very interesting because it's just sitting still. So stationary motion, or not moving, if you plot it on a distance time graph, then not moving is a flat straight line. All right, that's pretty basic. A second kind of motion that you can graph on a distance time graph is constant speed. So this is a graph of something that's moving at constant speed. So what does that look like? Again, we already mentioned this on the first slide. It is a straight line with a constant slope. All right, and the slope of the line is equal to the speed, the average speed. Well, actually, the average speed is the constant speed because it's moving at the same speed through this whole period of time. So, so we could calculate that if we had numbers here. You would just do rise over run, rise over run, and you would be able to find out the slope of this graph, and that's going to equal the speed. So on this kind of a distance time graph, the slope equals the speed of the object. All right, and the speed is constant. So if you find the slope, you find the speed. Pretty cool. All right, so that's our second example of what motion looks like on a distance time graph. Now the last example is this one, and in this graph, what we have is changing speed. Now this could be This is not the only way this could look. I mean, this is basically speeding up. The speed is increasing here because the slope is getting steeper upwards. It would be entirely possible for a graph to, with changing speed, to look like this, right, where it's slowing down and maybe even coming to a stop. And if it stops, it would then be a straight line. All right, so basically, since this is not a straight line from there to there, it is a curved line. That means what we have is a changing speed. The speed is not constant, and that's what this looks like on a distance time graph. All right, it would look different on a different kind of graph, but on a distance time graph, changing speed looks like this. All right, we could still calculate the average speed of this if we wanted to, and in order to do that, we would need to just basically take the start here, what that point is, and then this point, and you could do rise over run. For that, basically the average speed would be the time here, you'd subtract them from each other to find how much time has passed between that point, and then you would find the distance that has been traveled, which would be from there to there. So you could find the average speed because you can find the distance that has been covered, right, which is just this distance vertically on the graph, and you could find how long it took, and that's the horizontal distance. So remember, average speed is just concerned with where you start here and where you end there. It's not concerned with how the speed changes in between. All right, so we could still calculate average speed there if we wanted to. So that is the three different things you can plot on a distance time graph, and then basically what they look like. All right, and we'll work again more with this in class.